Unit 8, Lesson 4, Estimating Probabilities Through Repeated Experiments. So I can explain whether certain results from repeated experiments would be surprising or not, and I can estimate the probability of an event based on the results from a repeating experiment. So we're going to do some experimenting. So they need to drag and drop. So if you were doing this on a Google slide, you would drag and drop these. So they want us to put these numbers on the number line. Well, I know 0.5 is halfway. I know 0.75. Okay, and I know 0.25. Those are some of the easies. Now I know 0.33 is going to fall somewhere in here. And I know 0.67 is going to fall in there. All right, so the first activity we're going to do is called the long run. So Mai plays a game in which she only wins if she rolls a 1 or a 2 with the standard number cube. Check out her data on the table and graph. What is changing in the table or graph? Well, okay, so if I look, the rolls are going up. The number that she rolled is going up. The total number of wins, and then if you look, the number of games is the same as the number rolled. So what's changing, if I'm looking at it, things like the probability, of winning, the number rolled, you could say the number of times rolled, and for the graph you could say whether it's going up or down. So there were a lot of things. So if you were in Pear Deck, you would be typing in one of these types of things. All right, so what is the probability that Mai will win the game? Explain your reasoning. So if I go back and I look, it says she has to roll a 1 or a 2 on a number cube. So the desired outcomes would be a 1 or a 2, and the total outcomes would be a 1, 2, 3, a 4, a 5, or a 6. So that would be 2 out of 6, or you could reduce your fraction and say 1/3. So either of these would be acceptable outcomes. All right, probability tells you how likely an event is to occur. It is not guaranteed to be an exact match. So if the experiment is repeated many times, the fraction should get close to the calculated probability. So that means that when you do the experiment, so if we were in class right now, we would be flipping coins, stuff like that, and checking our experiments. So the more times you do it, the closer it's going to get to what the probability should be mathematically. So like in a perfect world. So due for a win. So it says the probability of a coin landing on heads after a flip is 1 out of 2. So there are 2 possible outcomes, heads or tails, and getting a heads is one of them. So we have to decide if you think the situation is surprising or not, and is it possible. Be prepared to explain your reasoning. So if you flip a coin once and it lands heads up, is that surprising? No, that's not surprising. Is it possible? Yeah, it's possible if you're flipping a coin. You flip a coin twice and it lands heads up both times. Well, I don't think that's all that surprising either, and it is possible. You flip a coin 100 times and it lands heads up all 100 times. Now that's pretty surprising. But is it possible? Yes, it's not impossible for the coin to be heads up. Now is it likely? Is it certain? Is it likely? Is it even equally likely? No. It's unlikely that that would happen, but is it possible? Yes.
Mom?
Hang on, Isaac.
You
No more waffles. If you want a banana, ask Ian. If you flip a coin 100 times, how many times would you expect the coin to land heads up? Well, I would expect it to land 50 over 100 because the probability is 1 out of 2. So I can, if I'm going from 1 to 50, I'd multiply by 50. 2 times 100 times by 50. All right, so probability represents the expected likelihood of an event occurring for a single trial on an experiment. Regardless of the previous tries, each coin should still be equally likely to land heads up as tails up. So just because you've been flipping the coin and you keep getting heads doesn't change the probability that that it's equally likely to get heads or tails. A basketball player who tends to make 75% of his free throw shots would probably make 3 out of 4 free throws. He attempts, but there is no guarantee, and that's important, there's no guarantee that he will make any individual shot, even if he has missed a few in a row. So let's say he misses one. So he missed 1 out of the 4 shots, right? There's no guarantee that he's going to make that next shot. He could miss it again. It's just his overall probability is 3 out of 4. Meaning that if the experiment was conducted multiple times over and over and over again, he would get a 3 out of 4. All right, you conduct a chance experiment. How many times you conduct a chance experiment many times and you record the outcomes. How are these outcomes related to the probability of a certain event occurring? Okay, if it was a certain event, then that would be, so the probability of a certain event occurring. So if the event was going to occur, the fraction of times the event occurs after many repetitions should be fairly close. So that means, so it's fairly close to the probability. So the more times you do the experiment, just like I've already said, the closer you're going to get to the expected probability. So the expected probability is the mathematical probability, what should happen. All right, so what is the probability of rolling a 2, a 3, or a 4 on a standard number cube? Well, a 2, a 3, or a 4. So that's 3 out of 6 possible outcomes. Oops, I didn't mean to do that. Which would be 1 out of 2. So I can reduce my fraction. So the desired outcomes, there were 3 desired outcomes out of the 6 possible outcomes. All right, if you want to roll a 2, 3, or 4, and you roll 3 times and none of them is a 2, 3, or 4, does the probability of getting one of those on the next change with the next roll? No. So the question is, if you ended up getting a 1, a 5, and a 6 on those first 3 rolls, does that change the probability? No. There are still 3 possible outcomes. Out of 6. Okay, so circle how you're feeling. So if you were as part of the lesson right now, you would tell me how you're feeling right now, if you're feeling good about it or not. Okay. All right, so this is our cool down image. So the librarian is curious about the habits of library's patrons. He records the type of item that the first 10 patrons check out from the library. So based on the information from these patrons, so these right here, estimate the probability that the next patron will check out a fiction book. Explain your reasoning. So they're telling you the item type, and they're telling you that there were 10 people. So they want to know what is the probability that somebody's going to check out a fiction book in the next person's going to check out a fiction book. So they give you all the different types of things people have checked out. Make sure you submit your assignment. I hope you have a great rest of your day.